Dear students, welcome to this tutorial video on conduction. In this video, we're going to be exploring how to solve a simple problem on conduction. So we have a sample problem already, and I'll read it out and then we'll begin to solve it. So the problem is that a metal rod that has a cross-sectional area of 0.2 meter square and a length of 1.2 meter. That metal rod is made of aluminium alloy, which has a thermal conductivity of 74 watts per meter per Kelvin. Now, if the temperature at one end of the rod reaches 200 degrees centigrade, while the other end is at 25 degrees centigrade, the sample problem says that we have to find out the heat transfer through the rod by conduction. So, whenever you have to solve such problems, the best thing to do is to write down the equation. And we covered in the last lecture that the equation for solving conduction problem is called the Fourier equation, and that is Q equals to K times A times delta T, which is the temperature difference, divided by X, which is the thickness. So I'll go through the equation as again. Q is equal to Ka delta T by X. K here is the thermal conductivity, A is the cross-sectional area, T2 minus T1 is the temperature difference, sometimes called delta T, and X is the thickness. Now let's go through the problem again, and what we notice is that we have been supplied all the values here. So thermal conductivity K is given, which is 74. Area A is also given, which is 0.2 meter square. T2 and T1 are also supplied to you, which is 200 degrees and 25 degrees. And now notice that when you're solving conduction and convection problems, you don't have to convert them into Kelvin, because temperature difference in centigrade is the same as temperature difference in Kelvin. So we don't necessarily have to convert it, but if you want to, you can. However, for radiation problems, that's a different story, and when we're solving radiation problems, you'll notice that we must change the temperature into Kelvin. Anyway, coming back to our equation, Ka T2 minus T1, which is 225 degrees respectively, and then we have the thickness or the length of the rod, which is 1.2 meters. So if we supply all those values here, so that would mean 74 times 0.2 times 200 minus 25 in brackets divided by 1.2. Now a lot of students would get this wrong here. Why? Because a lot of you don't apply the simple Bodmer's rule. So in a simple equation like this, make sure always to solve the bracket first. So that would mean that Q would equal to 74 times 0.2 times 175, and all of that would be divided by 1.2. The solution in this case is that the total heat loss by conduction Q would be equal to 2158.3 watts, and that's the answer. So if you get a sample problem or another problem like this one, so you should be able to solve it. Thanks for watching this tutorial video.